Hello and welcome to today's topic of inductance. Inductance, what happens is, for the principle of electromagnetic induction to work, we need to have flux change linked with a conductor coil by using a magnet, or not by, you can say not by using a magnet, but by changing the magnetic field of a magnet continuously. A flux linked with a coil can be changed, which induces an EMF in the coil. But instead of using a magnet, can we use an electromagnet for the same process? So an electric current when can be induced in a coil if the flux change produced by another coil in its vicinity by the use of simple electric current or a use of electromagnet. See, in both the cases, the flux linked through the coil is proportional to the current. So if we use an electromagnet, the flux linked with this coil is also directly proportional to the current flowing in the coil. Moreover, the flux linked through this coil would be dependent on the current changes in this coil. So the flux linked with inductor is also directly proportional to current. Let's say there are n number of turns available. So the rate of change of flux in the coil should be equal to rate of change of current times n number of loops available. So when the flux change through a coil changes and each turn contributes to the induced EMF, in that scenario we have to induce a term called flux linkage. So the flux linkage due to a coil which has a number of turns, the flux linkage n phi b should be equal to current flowing in the circuit. This not equal to, should be directly proportional to current. So when we remove this directly proportionality sign, then the constant of proportion in this scenario, proportionality in this scenario, is known as inductance. Constant of proportionality for such coil, where for such an arrangement, we can say in this scenario the constant of proportionality between current and the flux change is inductance. Moving on to the next slide, we would see what is inductance. So the general definition of inductance is the inductance is the property of a conductor which is measured by the size of the electromagnetic force or the voltage which we have used or what current we have used. So the rate of change of electric current that produces the voltage. So inductance is the property of a conductor which is measured by how much rate of change of current is used or how much electromotive force is used or what voltage is used to create the electromagnet. So inductance is a scalar quantity and the dimensions are given by, it is written here, ml square T inverse 2 A inverse 2, and the dimension of flux divided by the dimension of current. This is how the inductance dimension is calculated. As far as the SI unit of the inductance goes, it is denoted by Henry, obviously by the name of the scientist who has first introduced this phenomena. So this is basic inductance. So in the upcoming slides, we would study what are the types of inductance and how these two different types of inductance, which we would study in upcoming slides. We would see how these are linked. What are the formulas used for calculating the magnetic field in case of inductance? Thank you.